Okay, Lila, today we are going to talk about a conjugate or conjugates. What is a conjugate? Another one of those $10 math words. Well, think of a conjugate as a way to pair something similar or something very similar version of itself, but with one sign flipped. What do I mean by that? Well, say I had the term um, so here's an example. Say I have the term A plus B, just a general term or expression, should say, an expression with the terms A and B and the plus sign between them. Well, its conjugate would be something very similar to it, A minus B. Well, where's the similarities here? Well, the terms A and B are there, right? So there's the similarity. Where's the difference? Where's this one sign flipped? Well, the sign is right here. We went from A plus B to A minus B, right? So it's very similar, A and B, but we're flipping the sign for going from addition to subtraction. If I had A minus B, its conjugate would be what? A plus B. The A's and the B's are the same, those terms in the expression, but we're going to flip the sign. Well, we come down to the question, who cares, right? Who cares? Well, when it comes to radical expressions, in this next section, we're going to come across problems where the denominator, specifically the denominator, has a radical in it. It's going to look a little bit different from the other videos we've done. When you multiply a number by its conjugate, this is just in general. When you multiply a number by its conjugate, the middle term cancels out. So think of this whole thing like A and plus B as a number, A minus B, that expression is a number. They cancel out. Let's look at an example with an actual number. Let's use the term 3 plus square root of 5. Now, this is technically a number, right? Because this is 3 is 3. This is 2 point something. 2 point la 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 la. Irrational, right? Because it's over 4. If it was 4, it'd be 2 exactly. But it's 5 and a bunch of decimals. You add them together, it's going to be, 3 plus 2 points. So 5 point something, off into the night, irrational number. So that is a number. If I multiply it by its conjugate, well, what's its conjugate? Times 3, square root of 5, those are the same. What is different? The difference is the minus. That makes it the conjugate, the minus sign. What happens when I multiply it by its conjugate? Let's think about FOIL. First terms, outside terms, inside terms, last terms. Okay, so let's multiply this. 3 times 3, 9. That's the first terms. Outside terms. Negative 3 square root of 5. Inside terms. Positive 3 square root of 5. Last terms. Negative, what is that? Well, it's square root of 5 times square root of 5, which is just 5. What do we notice? What do we notice here? The outside terms and the inside terms cancel out. And we're left with 9 minus 5, which is just 4. So we want to think of a conjugate as a cancel out partner, and it cancels out the square root. The square root's gone. We're left with a whole number. And this is going to be very key when it comes to rationalizing the denominator in these next set of questions. Let's take a look at the first one. We are told to simplify 2 over 5 minus square root of 3. Very similar to what we had before. Instead, it was 3 here, right? That last example I was showing. And this was square root of 5. In this case, it's 5 square root of 3. How do I get rid of this? How do I rationalize it? Multiply by the conjugate. 5 plus square root of 3. But we got to do that on the top too, right? 5 plus square root of 3. Well, let's multiply the numerator first. That's just 2 times 5 plus square root of 3. What about the bottom? Well, remember, when we multiply the conjugate, the outside and the inside really doesn't matter that we do it, right? Because they cancel out. So all we have to do is multiply first term, multiply the last terms. We know we're good. First terms, 5 times 5 is 25. Last terms, negative 3, square root of 3 times positive square root of 3 is a minus 3. We're left on the bottom with a 22, right? 25 minus 3. And then we can divide out a 2 on top and bottom. And we're left with what? Top will be 5 plus square root of 3 over 11. So multiplying by the conjugate here allows us to rationalize that denominator. And did we rationalize it? Yep, there's no more radical in the denominator. It's just 11. Let's try the next one. This time we have a radical top and bottom, but really what we're focused on conjugate-wise is the bottom, because that's what we need to get where we need to get the radical out. So let's multiply by the conjugate of 6 plus square root of 5. It'd be 6 minus square root of 5. That's the conjugate. Top and bottom, we need to multiply that. So the top, square root of 5, times 6 minus square root of 5. We'll just write it all out here. The bottom, we know we're just concerned with first and last terms, right? For our FOIL, because outside inside is going to cancel. 6 times 6, 36. Square root of 5 times negative square root of 5 is a minus 5. We get what on the bottom? 31. Now, let's do some distribution on the top for the numerator. That's 6 square root of 5. Make this a little bit longer here. And minus 5. Why is that? Because we got square root of 5 times negative square root of 5 is a minus 5. That is the most we can simplify. 31's a prime number. Doesn't really matter if we distribute anything out. We can't really do anything else. We can't cancel anything else out of this one, so we're done with that one. Last one, square root of 3 over square root of 7 plus square root of 3. Focused on this last one here, or the bottom one, square root of 7 plus square root of 3, multiplied by the conjugate, which is what? Square root of 7 minus square root of 3. Well, let's just distribute that across on the numerator. Square root of 3 is going to be multiplied by, on the top here, it's going to be multiplied by, or to both of these, right? So this is going to be, let's see, square root of 3 times square root of 7 is square root of 21. Minus square root of 3 times square root of 3, that is 3. What about the bottom? Well, remember first and last on this one because we're multiplying by the conjugate. Square root of 7 times square root of 7 is 7. Square root of 3 minus square root of 3. I'm sorry, square root of 3 times negative square root of 3. That is minus 3. And we would have what? Final simplification. Square root of 21 minus 3 over 4. That would be our answer.